Good day, everyone. My name is Chulonga Mlinjendibo. I am a master's student at the Tshwane University of Technology. And my conference paper is titled The Priority-based Congestion Control Algorithm for On-Road Traffic in Smart City. So this is the outline of how I have structured today's presentation. I'll start with the introduction, the problem statement, the objectives of this study, related work, overview of wireless sensor networks, their approach, contribution of the study, future work, and the conclusion. Now, we're starting with the introduction. Wireless sensor network is a system that monitors and controls events remotely. Wireless sensor network composed of sensor nodes that interconnect with each other wirelessly and form links. Sensor node can sense, process, and communicate wirelessly in a harsh environment. Wireless sensor networks are primarily for traffic communication in a wide range of environments such as smart city, healthcare, homes, and military areas. The implementation of wireless sensor network in various environments such as smart city come with different challenges such as traffic congestion. Now moving to the problem statement. The traffic congestion that occurs on road within smart cities during peak hours such as going to school, going to work, coming back from work, lunch break. This traffic is caused by numerous vehicles traveling at the same time, resulting in traffic jam, time delay, and cause accidents as well as noise pollution. Now, let's focus on the research objectives. The first objective being to identify and analyze the current algorithms used in traffic congestion. The second one will be to design the proposed algorithm, which is the Priority-based Congestion Control algorithm. We're going to design this by integrating two algorithms, namely Fusion-based Intelligent Traffic Congestion Control and Traffic Congestion Detection algorithm. The third objective will be to implement the proposed algorithm to reduce and control traffic congestion and improve traffic flow. Lastly will be to evaluate the effectiveness of the proposed algorithm being the Priority-based Congestion Control compared with the current algorithms in place. Now moving to the related work. This section presents a portion of related work that has been conducted on on-road traffic congestion in wireless sensor network for the past decade. The first one that we're going to look at, it's a new adaptive traffic light control system. So this was proposed to assist traffic management authorities in efficiently reducing the traffic congestion in smart cities. The author aimed to achieve this by synchronizing a number of traffic lights controlling consecutive junction by creating a delay between the times at which each of them switches to green in a given direction based on the load of vehicle in that area. And the limitation of this study was that it does not consider the emergency vehicle which are on the other direction of the road. This remains as a problem. And the second related work was a congestion-aware routing using fuzzy rule set. This was proposed to handle the estimation of congestion level and access traffic condition in smart cities. The author achieved this by identifying the non-localized nodes path and adding them into the existing localized node path. And the limitation of this study was that it does not consider the traffic congestion index when estimating the congestion level in smart cities, which still remain as a problem. The third related work is the fusion-based intelligent traffic congestion control system. This is for vehicular networks. So this was proposed to elevate traffic congestion by controlling traffic data on the available routes within the smart city. And the limitation or gap on this is that it did not consider the amount of data traffic that exceed the real-time pollution management sensor capacity. So this real-time pollution management capacity is the type of sensor that is used to collect data in a smart city. And the last related work is an intelligent traffic management system. So this was proposed to predict the optimum route based upon vehicle categorization, accident occurrence, and the level of precipitation. Now moving to the overview of the wireless sensor network in the smart city. Wireless sensor can measure environmental conditions such as traffic density, sound, noise pollution, humidity, temperature, among many other, depending on the functionality of the sensors placed within an environment. Sensors can transfer data that is collected from the smart city road. These are the sensors that are interconnected with the roadside unit transmitter, which is mounted on the road or pedestrian passageways, and the onboard unit, which is installed on the vehicle for traffic record. Therefore, the data collected is transferred to the central device. The central device are the nodes that receive the data from sensor nodes such as sync node and base station. This figure that you see demonstrated here, it shows that the sensors are placed near the road where there are movement of vehicles so that the sensors can be able to collect data. The sensor nodes that are placed near the road have the capabilities. They've got the capabilities to sense and collect and transfer the data from one node to another. Then the sync node receives the data from the sensor node, and then the data can be transferred to the internet, where it is stored on the management node, which in this scenario can be the server. Therefore, the users will then be able to access the data via the internet. All sensor nodes share a single communication channel through multiple access protocol, for example, random access protocol and media access protocol. Now let's move to the approach. The proposed algorithm in this case, which is the Priority-based Congestion Control, it's designed by integrating fusion-based intelligent traffic congestion control and the traffic congestion detection algorithms. The proposed algorithm uses machine learning techniques such as decision tree, support vector machine, k-nearest neighbor. It uses those techniques to allow drivers to view traffic flow and the volume of vehicle available on the road remotely, intending to avoid traffic. So the fusion-based intelligent traffic congestion control algorithm estimate and classify the congestion on the road within the smart city. This algorithm as well uses machine learning to predict future trends and events based on historical data. And the traffic congestion detection algorithm detects the traffic congestion in real time without any human intervention or prior knowledge. This algorithm uses different performance metrics such as false alarm rate and mean time detection. It uses this metric to detect the traffic congestion on the road. Well, furthermore on the approach, for those who want to see how the equations look like, this paper applies the technique used by fusion-based intelligent traffic congestion control algorithm to estimate possible on-road traffic congestion before occurring, so that road users or drivers may be aware of possible delay on a certain lane within the smart city. On the first equation, where the TP represents the estimated total number of vehicles within the city, the VI represents the set of vehicles in motion within the city. The PI represents the vehicles which are in stationary mode. Meanwhile, PJE represents possibility of traffic congestion within the city. Well, looking at the equation 2, CN representing the classified number of vehicles detected in the oncoming lane within the city, DP representing the delay caused by incoming vehicle, while TC represent the time per second taken by the incoming vehicle. Now let's move to the contribution of the study. This study is intending to develop an effective algorithm, which is the priority-based congestion control algorithm that will manage the traffic congestion while improving the vehicle movement in the smart city using the wireless sensor network. The second contribution of the study is that the proposed algorithm will select the most cost-effective path for vehicle and give priority on different vehicle movement in the smart city. The future work. The issue of data security was not taken into consideration in this research, unfortunately. Therefore, it is important to consider the data security even when using this proposed algorithm. The conclusion: wireless sensor network has become a revolutionary technique of data collection used every day worldwide. Furthermore, wireless sensor network became a popular technology in a way that it is used in different areas such as smart city and farming for monitoring purposes. Hence, the on-road traffic congestion management is required in a smart city to monitor the congestion caused by vehicles. In this research paper, the proposed priority-based congestion control algorithm was demonstrated in order to overcome the road traffic congestion within a smart city. The proposed algorithm will minimize the congestion rate and time delay caused by traffic congestion. Furthermore, this paper aims to reduce air and noise pollution, traffic density, and longer travel time within the smart city. And these are the references that I've used for this research study. I'm not going to mention them one by one, but I felt it's very important to have the reference slide. So I've got 2 slides. So it's the first one and the second one. And thank you so much for giving me this opportunity to present my work to you. Enjoy the rest of your day.